Very good afternoon, everyone, and once again, welcome back to the session. So, to begin with, we were discussing something about the basic stats. And so, let's continue with the same. Right. So, yeah. So, we have understood that using visualization techniques, we know that we can identify outliers using box plot. Box plot's main purpose is identifying outliers, and it also helps in understanding the distribution or shape of the distribution of the data. Then we also know the different techniques you will follow to identify the outliers, right? So when you are trying to identify these outliers, right, you will check for interquartile range. Based on that particular formula, you will move forward and take a call whether it is an identified as an outlier or not. Now, so when we are discussing about this missing values, right? When you talk about missing values, right? What are the things we need to understand as a part of missing values? Is it easy to work with missing values, or what we have to do to identify the missing values? What techniques we need to follow for missing values? How can you move forward with missing values? Because the data which is being generated, there will be few people who don't like to expose the data, right? So what they have to do, they will not disclose their data. So in that scenario, what you have to do, you have to identify those outliers. You have to check whether all the data is available or not. If the data is not available, then you have to take a call, right, to fill that particular columns with outliers, right? So if someone asks you this is a thing like, do you think missingness of the values, otherwise missingness of the values will impact your analysis? Yes, right? Definitely, it's like yes. The answer would be yes. Why? Because whenever you are given a data set, you're working with any data set, what is that you are trying to do here? You will check, right? If the data is like this, you have the missing values here and there in the entire data set, right? These are your column names. It could be anything: salary, age, experience, income. These are the people's data, right? Suppose we have to replace with some value, if at all you have here and there NA values. Because if at all you don't do or don't identify any missing values, what happens here? This entire row, suppose this is 1, 2, so the entire row would be not considered. It would not be considered. It deletes that entire column. Suppose you have 100 data points, 22 persons data, only one column, income column, is not available for that particular person, right? So you have Y, X1, X2, X3, X4 and X5. Now this is NA. All other values are there. So what will happen here? It would delete this entire information about that particular person, number 22, right? So if two values are missing or one value is missing, entire row would be deleted. So because of this, the data is getting deleted. We have to spend, it is impacting our analysis. We have to spend a lot of time here on our missingness data or missingness of your data, right? Then how do you do to resolve this issue of missing values? Is there any need to impute the data? Is there any need to impute the data? Of course, yes. Right? It's very, very important that you do impute the data. So there are various types of missingness, and because of that missingness, it could be any reason. Maybe that particular person is not interested to disclose his details. Maybe by mistake that particular data is not entered into the table, right? So there are various types. So if you make a note of various types here of missingness, so various types of missingness. How do you start with missingness at random? Right? You have missingness at random. So you have the student's data, and the student is very, very good, right? But for some genuine reason, he did not appear at the exam, right? So it's not with one person. Now it could be 10 people, or it could be 4 people. It could be anything. Student 1, student 2, student 100. In between, the data is empty. No information. Don't know what is the reason here. Some genuine reason might be there. So his data is missing, right? So if at all you are talking missingness completely at random, right? You have something called as missingness completely at random. What does it do here? It is equally linked with your missingness at random, completely at random or missingness at random. Both means to be same. Maybe a student, he started from his home, but he could not reach the examination center due to some reason. Maybe he missed his hall ticket, or he forgot something else. So he was not alert, not on time. So completely random. That thing which happened, you are expecting him to reach the exam center and write the exam, but he did not, right? So missingness at random, missingness completely at random are closely related here. So anything is ignored, you might miss something which is very, very interesting. There should be very good, maybe there could be some very good insight which you missed out, right? Which you might have missed out. Sometimes missingness not at random. There's one more, not at random. What is this? Here wantedly they are not disclosing their data. It is purposely not given to you. So if this is purposely not given, this would give you definitely incorrect results once you start analyzing it. Right? Once you start analyzing it. Now, what are the techniques you have to follow to fill this data? Somehow data is missing, whether it is wantedly not given or by mistake it is not entered, or it randomly it missed out, whatever might be the reason here, but you have to fill those missing values, right? So what is the technique you call it as? We call that particular technique as imputation, right? You do imputation. So whether it is your mean imputation, right? Whether it is your median imputation or mode imputation, hot dog imputation, regression based imputation, KNN based, right? You can give a try with all kinds of imputations depending upon the type of data you have here, right? Depending upon the type of data you have. So missingness is very dangerous scenario. It will result into wrong analysis. So what you are doing? You are doing imputation. So what is this actually does here? What is this imputation doing actually? See, generally, whenever you're talking about ML algorithms, right? What is the thing you have to do? You will have numeric data, mostly numeric data. Sometimes maybe your target variable is categorical, right? So whether this median and mean imputation, it is very good for non-missing values in a column, replacing entire missing values, the blocks what are empty in this entire data set. You calculate the average of this particular column, whatever the average is there. For example, it is 3.3. So you fill those missing values with mean or median. So it is something like I have column 1, column 2, column 3 and column 4. Right? I have data here. I have no information. Right? Again, I have 9, some no information. How many columns you have? First person, second person, some random data I'm writing here. Right? Take the average of this two, take the average of these two, whatever is the average, fill it. Take the average of this column, whatever is the average, fill it. There is no other option here. 7. So take 7 only and fill it with 7. So if at all you talk about the pros and cons here for this particular median and the mean imputation, first is it is easy and fast. Right? And it works very good for small numeric data sets. It works good for small numeric data sets. But sometimes what happens here is, right, they may not give you appropriate results. There is a chance, right? So what we can say, it does not factor the correlation between the features. So mostly, finally, we can put one as not very accurate. Right? Then you have something called as median or mean. Then the second technique what you have is using the most frequent, right? Most frequent means you are trying to calculate most repeated value mode. So this is used mostly for your categorical features. Right? By replacing the missing data with the most frequent values with each column. So what would be the advantage? Definitely, when we talk about this is for only works well for categorical features, but sometimes maybe there is a chance that it would introduce bias in your data, inclined to some value. So it is not that preferred sometimes, right? There is one more thing which is called as zero constant imputation, right? Zero or constant. So what is that we are doing here? In zero, the name only will is suggesting us that you are trying to impute using either all the NaN values in your data set, NA value, NA value, NA value. And this would be filled with zero or any constant value what you specify, right? Any NaN value what you specify, right? So if at all you are going for this, you can also go for random imputation. You will also go for one more technique which is called as random imputation. Why you have to focus on all these imputation techniques? You apply one imputation, you build your model, you move forward, try to evaluate your model. If that is not giving fruitful results, you get back to the step of imputation. What happens in random imputation? For every column, you take the maximum value, you take the minimum value, whatever the values you get, whether it is 0, suppose it is 15, you randomly pick one value between 0 and 15, right? And you fill those NA values. Any value between 0 to 15 randomly, right? So there is one more thing which you call as hot deck. What happens in that? Many are there. This is also one. There is no restriction. Why are you choosing only this? So hot deck, what does it do? You have column 1, column 2, column 3, column 4. It would check 1, 2, 3. This is missing, right? So if all the three are relatively matching, right, it would take this value and fill it up here. It will travel downward. Assume some more data is also there here. It will travel downward and looks at it and says which of them looks at the similar rows. So in that way, it keeps on traversing down. Wherever it finds the similar values, it will fill that. This is very, very rarely used technique. Very rarely used. So it will check for all the values relatively matching. One is not missing. It would take a call on that particular value. Okay. So this is your one hot deck. Now what is this KNN? Imputation can be done using KNN. So this is a classification algorithm. It uses something called as feature similarity. It uses something called as feature similarity. So this is very useful in making predictions about missing values by finding NN. NN stands for KNN. So nearest neighbor. Right? This is very useful here. It takes KN, means closest neighbor to the observation with the missing data. So case, it could be one closest observation, two closest observation. Now K is a parameter which is changing for us. The case closest neighbors with the missing data, imputing based on the non-missing values in the neighborhood, in its neighborhood. Okay. So there are very good advantages here. It tries to match now. which is near, which is near. It would try to check the nearest neighbor. This is much more accurate, when compared to mean, median, or most frequent imputation methods. But the disadvantage here is it is quite expensive. And also, this is quite sensitive to outliers in your data. Right? So you have a library, right? It is IM library. This provides a simple and easy way to use KNN for your imputation. Right? Something like dot imputation. From impute you take imputation module. In that you have .cs. From that you import fast underscore KNN and you do this. Right? So these are the various imputation techniques. Right now, as I told you already, we are not restricting ourselves to one kind. Right? So there is no perfect way to do the compensation for the missing values. Maybe if this strategy would perform differently, it can perform better for certain data sets. Other type may perform different for a different type of data. So there would be some set of rules which strategy you have to use for what type of missing values, particular type of missing values. But you should not stop there. Beyond that, what you have to do is you have to do some kind of experiment and check the model, what works best for your data. Right? So we have seen various types of missingness and also imputation techniques. Right. Now, what is this typecasting? What is this typecasting? Usually when you use this, it is also one of the pre-processing technique. It is a part of your data cleansing. Right? Most often you use this. You can use it for conversion of a numeric data also, but probably will not use always for like much will not use with that, but maximum is used when you have categorical data. Right? So when you're talking about categorical data, you know that you are not doing any operations on that, math operations on that. So what you have to do, whatever you have category, one, first thing is that you should understand, suppose this is, it could be x1, x2 also could be categorical data, right? Not only always y. So what happens here, when you have your x1 and x2, right, you may have 0, or you may have male, female, 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 like this data, right? So if at all you are passing this data as is to your model, you're passing this as is to your model, what happens? The model will not understand. Maybe your x2 is continuous data. This is your character data. What happens here? You are just writing y, x1 and x2 are your inputs, you are passing these two. Then what happens? It will throw error. It says that what is that you are passing. Right? So what happens here? When you are trying to have character data, most often you have to check whether it is converted into the format which is understandable to all the machine learning models. Mostly it is important that you do have to convert your character data, whatever character data is there, to factor. The process what you are following here to do a conversion right? The process what you're following here to do a conversion from a character to a factor data, you call it as typecasting. Right? The process is called as typecasting. So it's normally you all know that it is male and female. How do you do a check here? Once a data set is given to you, you should do structure of your data set name. Right? You do structure of your data set name. Then y, x1, x2. Whether it is integer, whether it is numeric, you get it as character. But here what you have here, male and female. The data is like this. Numeric means 1, 2, 3, 4, 1, 2.2, something like that. Integer means 1, 2, 3, 4. This is what you have, the count data. So this is character. You can't pass as is, no? So what you have to do, you have to convert it using as dot factor that particular column x2. This would make your data into factor and it would check how many levels are there in your data. How many levels are there here? Male and female. 2 levels are there, right? Male and female, you have 2 levels here, right? Any variable, now what is this factor? That is also one of the question, right? Any variable which takes minimum values, right? Any variable which takes minimum value. Gender is minimum, right? It could be male or it could be female, right? It is a factor data. So it by default what happens? It will give you, once you convert it, it will say that it is 2 levels, right? It will say male and female, it could be any order. Order means this is a data, it's something like that. It would take and give you the result as I'm converted into factor data and has 2 levels. So here it would change fact character to factor. Right? We have 2 levels. So any character data, you are doing it. It's not restricted to character as I told you. You also can do it for integer to float also. Forcibly converting one format to other format. Right? That is your type casting. Right. Now, when you are talking about typecasting, we also know now something which is important is discretization. Right? What is discretization? This is also one of the pre-processing technique. Why? What is the purpose of discretization? Always once the data set is given to you, do you check that? Do I have to do imputation? Do I have to do discretization? Should I have to do dummy variable creation? Shall I have to even do typecasting? Not required every time, right? Because for all different types of data sets, one or the other pre-processing is required. We will write purpose of discretization. What is it actually? Why it is required here? What would you do in discretization? Because we are always not getting the same kind of data, right? All your variables could not be numeric. All your variables will not be what you call it as categorical, right? It should be. It could be like a combinational data, right? Now, why this is important? Because when we are trying to do some math problems with continuous data, you have infinite numbers there, right? So because you know that continuous data is measured, discrete data is counted, and we have to do some kind of manipulations to your data so that everything comes into the same level, right? So data scientists require using data discretization. For many, they have to spend a lot of time here also, right? So first, it should fit your problem statement, right? And also, so when I already told you, it's the same thing for factor, incompatible with models and methods, right? So because of that reason, and something like it has to interpret the features also, right? Continuous features have a smaller chance of correlating with target variable, right? And they may have complex non-linear relationship here. Why? Because you will have something called as degrees of freedom. Infinite number of degrees of freedom is possible if you have the continuous data. Because our calculation should not go on and on every time, right? So it's a process where we transform your continuous variables into discrete form, right? We can do it in many ways. We can do it by calculating the bins, giving the number of bins, right? So whenever you are trying to do an approach for discretization, right? Sometimes you may have equal width, sometimes you may have equal frequency, right? Sometimes you go for different techniques which are apt. So this process, what you're following here, it's up to you that you want to divide the entire continuous data into how many categories. It's up to you now. You may convert the entire continuous data into multiple category, or it could be converted into only binary category, right? It will be converted into only binary category. Why? Because when you take continuous means first thing income, because I write it in dollars, it is continuous. You have the column here. So what you are doing here, I want to convert it into discrete because the model will not accept. So I can make it into three categories, right? Category 1, category 2, or greater than 12,000, I can make it into category 3. This becomes your multiple. I even have an option, I can make it into 2, right? I'll make it as less than or equal to 10,000, greater than 10,000. A and B. This is called as binary. And this process is called as binarization. This is 1, right? So the purpose here is the model will not work, model will not accept, and these are the techniques what we are discussing, right? Sometimes what happens, when we discretize a model, we even try to fit it to binning, right? So reducing the impact of very, very small fluctuations in the data also. Sometimes what happens, the graph could not always be a very nice graph. There would be some kind of noise being generated in bins when you try to get bins here, right? So the small fluctuations, what you call it as noise. So when you try to do this noise should be reduced, right? You will perform something called as smoothing to reduce this noise, right? So when you do this, the binning, it will get smoothened, right? You get bins properly. Binning is a process for discretization, one of the process for discretization. So by smoothing technique, will remove the noise and you can perform binning. So each bin is more than, right, the fluctuations rate more than here. So it would reduce the noise in your data also, right? That is also one of the purpose. It reduces the signals to noise ratio. And it is incompatible with models. Why? Because few models are incompatible when it is continuous data. We have our random forest, decision tree models, right? So what happens? Definitely you have to opt discretization technique there also, right? So continuous data is nothing but know what you are doing. It could be any continuous data. It could be weight, it could be height, it could be anything. You will sort it, right? So you will do multiple categories or binary categories, or you are doing it through binning, right? These are the techniques, and this is the purpose of discretization, right? Now, if at all you are doing all these techniques on one data set, right? What is the time getting most of the time is getting eaten away by the 3 steps. Most of the things are, we are keep on checking, right? Is missing values are there? Are you having outliers? Does it require discretization? Right? So let's move on with one more deep pre-processing technique. And what is this other pre-processing technique is very, very important. Normalization. What do you do here in normalization? What happens in normalization, or we can say standardization? Are we applying both at a time? Can you apply both the things at a time? Or we can apply both, or we will apply only one at a time? Right? That is also one of the things, right? You have to take a call on that. Right? So what is that? Standardization and normalization. So definitely when you are checking your data, right? You have all the variables, right? Different units are there, right? Different units are there. X could be weight in kgs. This could be speed in kilometers, right? Or it could be height in centimeters. So all these are different variables, right? And how they are impacting on the output might be different, right? So we want to check whether the impact of all these variables on the target variable is same or not, right? Just because of units, you can't take a call and say that weight is influencing more. Just because you have here, if it is in meters, speed wins some 1,000 meters, it is there instead of kilometer. Right? You can't say that 1,000 is very, very huge number, so it is impacting your Y. You can't say height is there in centimeters, so next importance is should be given to X3 variable. So this scenario is wrong, right? So just because you are measuring with respect to units, your data is being captured because of units, you will not take a call on giving importance to the variables taken or getting influenced, right, on y. So should units impact your target variable? Not really, right? So if at all your units are impacting your target variable, you go and do normalization or standardization, right? If at all, it's up to you now. For a given data set, you can perform normalization to check your accuracy. If it is not good, then you can go and apply standardization also. Not both at a time, one after the other can be applied, and check which one is giving you the best results. So when you go for standardization, z is equal to x minus mu by sigma, right? This is given with a standard mean, and standard deviation is 1. When it comes to this, and know all the values, because this is 2-digit number, because it is weight. Speed without meters, no, it is 3-digit or 4-digit number. Height is 3-digit number. So 3-digit, 4-digit, 2-digit, all these numbers are of different numbers, right? It is 5-digit or 1-digit. All should be brought to a same scale here. So once you do this standardization, you calculate x minus mu by sigma. It is minus 3.14 to 3.4 range. All will fall in this particular range. Right? How do you check that? In R, you check it by writing summary. Right? In Python, you can check using describe function. Okay. So what do you do in normalization here? When you do normalization, all the values will be brought down to 0 to 1 range. Formula here is x minus, calculate the minimum value of x, calculate maximum minus minimum of x. All the values are brought down to the range, this range, 0 to 1. Here it is minus 3.14 to 3.14. There is no hard and fast rule for selecting any of the method. You can go with this or this. The choice is yours. Or both also you can try, and you can take a column which one you would like to choose. Right? Now, so these are a few things which you do as a part of your cleansing. Right? Even before we enter into the descriptive statistics, right? Now, what is this probability? How do you explain probability? What is actually probability? Probability is nothing but number of interested events by total. Right? We all know that number of interested events by total. And now you know that probability is again classified into, or you will have a variant like there could be a joint probability, or it is conditional probability. Right? Now, what is this conditional probability and joint probability? Are we using somewhere here while building these ML algorithms? Conditional probability is used widely. We have an ML algorithm based on conditional probability also. So what is this joint probability? The joint probability talks about the combination. But what about this conditional probability? We can say that in a simple way, we can say conditional probability is nothing but, um, condition is that a particular person is worried, a human being is worried about his airfall, right? Maybe it could be, condition could be anything, right? He may have used different shampoos, different treatments, maybe weather, pollution, stress, genetic reasons. It could be anything. So he's worried about the airfall, provided on condition that this could be any of the could be the reason. That is your conditional probability. And in simple, more simple words, you write it like this: assuming that event A has already occurred and you are using that results for calculating the probability of event B, right? Based on the event B. Now, how can you explain joint probability? What is this joint probability all about? So it's nothing but it's as simple as the same here. Conditions apply, both are different here. A should occur, then that output is taken considered for B. But here, joint, the name joint, right? They are occurring, two events are occurring at the same time, right? Both the events are occurring at the same time. There is nothing but you call it as joint probability. And you know, it's a situation where more than one observation can occur at the same time. Okay, more than one observation can occur at the same time. Okay, now what is this probability distribution? How would you explain probability distribution? So whenever an event occurs, right, when an event occurs here, every event or the chance associated with each event is what you are capturing, right? The chance associated with each event is what you are capturing. So what is that actually? An event has occurred and that event, what is the chance here? That event has occurred. So it is nothing but we can say that it describes all the possible values that a random variable can take within a particular range. Right? The range would be bounded between your maximum value and the minimum possible values. And you are trying to plot that particular values on a, try to write it in a table and plot a graph. So probability distribution, the possible value is likely to be plotted on a plot where you have your event occur on your x-axis and y will be your probability. Right? Y would be your probability. So it's nothing but whenever you are given any data, right? So you convert and try to calculate the probabilities and you try to plot that particular distribution of different probabilities for occurring of different events, right? So it could be a bell-shaped curve, it could be like this, it could be like this, it could be anything, right? So I'm distributing across all the random values associated with probability. So that's why that is called as your probability distribution. right? So we know two, three conditions here, right? When you are talking about probability distribution, if you are working with continuous data, you call it as continuous probability distribution. Types with discrete data, you call it as discrete probability distribution. Discrete probability distribution for discrete and continuous probability for continuous. Right? You have heads or tails. If you are counting number of books, any non-zero number, we can say that you have this. So, but when you just segregate all the discrete probability distributions, right? There are wide variety of discrete probability distributions. So the correct discrete distribution depends upon the properties of your data. Suppose your model has binary data, coin, tossing a coin. It is a binomial distribution, right? You have the count of library books checked out for 1 hour. We call it as Poisson distribution. You have something called as uniform distribution, where multiple events, all the events take the same value, right? All the events take the same value. Then you call that as uniform distribution. So this continuous probability distributions are also called as probability density functions, because that continuous means the values can take any value between minus infinity to infinity. Or we can say that infinite number of values can be possible between two values, like height, weight, right? So to find probabilities for continuous data, right, we are trying to measure over a range of values here, right? So whenever you talk, each probability distribution has a parameter. That parameter would define its shape, right? So specifying those parameters, you get the shape of the distribution. So by looking at the shape of the distribution, you will talk about many other descriptive parameters of your data, right? So the one word, if we write, right, we have a lot to understand with that particular word. That is nothing but your normal distribution. That is nothing but your normal distribution. So to understand when we talk about probability, right, then comes into picture the inferential statistics. Right? You talk about inferential statistics. If we talk about inferential statistics, how it is different from descriptive statistics? What happens here? Right? What happens there? That also should be understood by us. How it is different. Right? So what is that happening here in descriptive statistics? How it is different? What happens in inferential? What happens in discrete? Yeah. Because of that normal distribution to take to that particular concept here. So now, if we talk about this inferential statistics or descriptive statistics, inferential statistics is nothing but you are trying to make out samples. You are applying some condition called as sample frame, the funnel-like structure, what you have, right? So you are applying some condition because you can't work on entire population. You are trying to draw some inferences out of it, right? Such that you are trying to entire process of deriving results from a sample and you're generalizing it to your population. Only because you can't work on entire data, you are taking subset of your data, you are performing analysis and you are trying to get some insights out of it. After getting the insights, you are generalizing it to your population and assuming they may hold good or not, we don't know. You assume that the sample results They hold good for all your population also. So whatever subset we are talking is called as sample. The results you get on sample data are called as statistics. Hence the term inferential statistics. Right? You can also call it the entire process what we have discussed as a sampling funnel. What is the funnel shape? Right? You have your population, you have your sampling frame. You have the sampling frame, then you have sampling technique, then sample. So you are working on this, generalizing it to this. So it's a funnel shape, you're calling it as sampling funnel. So you are trying to get some inferences out of this, because whenever you work on population, whatever results you are getting, you call them as parameters. When you are working with sample, whatever results you are getting out of sample, you call it as statistics. Right? So that's why the term, we are working only with sample here, we are calling it as inferential statistics, because we are trying to get some inferences out of sample. Right? Now if someone want to explain, they want you to explain more about sampling frame. How do you start with? How do you explain the sampling frame? So whatever you apply on population, because the population is the entire data, in that you want to take only this square brackets data, right? That is your population. The square bracket what we have here is your, after you apply some condition on your population, you're getting only a subset. You're filtering out many things, many people, many data points here. So how do you get that? The whatever condition you are applying, that should be unique condition to work. There should be a way to identify each data point uniquely. Right? Each data point should be defined uniquely. Only then you can define the probability. So this you apply on sampling frame. The condition what you apply on your data. The very best example, if at all you are taking the elections in India, right? Who are all eligible to vote? If you take that, the whatever conditions you are applying here, people who have crossed their age of 18 years, who are this, who have this should be first, right? Citizenship of India, who have crossed 18 years, who all are have their voter IDs or your Aadhaar cards. Right? There are the three conditions you are applying on population. So many of the people would filter out of the population, because ultimately your goal is to get one sample. And whatever you're getting results, this one circle what I have drawn is your sample. You are generalizing the results of this onto a population. That is what is happening in sampling frame. Now the question comes, which technique? Because the third, right? You have population, you have sampling frame, you have technique to be applied, then you get the sample. We should discuss about the techniques. Different types of techniques can be followed to pick up the sample, and what should be the sample size. Okay, friends. So we'll stop here. Thank you all so much for joining the session. Thank you. We'll connect tomorrow, same time. Thank you, everyone.